So you're trying to make it fit with the W to the 12. It has to fit in that.
If it was a squares, yes. Is this a squares?
It's cubed.
Because I can break this up in half, and I can break that in half, but I can't break 8 up in half multiplicatively. Don't say 4 and 4, that's not 8, that's 16. I can't break 8 up in half multiplicatively, right? I can break everything up into 3 pieces. Therefore, it's a cube.
Yeah.
2 times 2, 2, 2.
If I can break everybody into 2 pieces, it's a squares. 3 pieces, it's a cubes. See, I don't mind spending this extra time in chapter 5 because, like I said, the easier 5 is. If you get factoring, 6 is going to be stupid easy. Because that's really the hardest part of most problems in 6 is factoring what they give you. And then you do a few steps after that, which will be easy once you've got everything factored. So if you understand factoring, 6 will be quick.
And an easy A on the test.
That's what I'm hoping.
I'm going to guess that you could have W to the 4th 3 times and 2A squared 3 times.
Yeah, so W12 in 3 parts.
W4, W4.
That's what I call it.
W4.
A6 will be 2A
Squared.
squared. Do you have to do that step? No.
But it helps.
It
But that's actually a way a student did it a while back, and I was like, that's a cool way to do it. I'm going to teach it like that. Bam. So I pick up a lot of my teaching tricks from my students.
So you got 1
first
W
term.
to the 4.
Yeah, so the little dude gets
W4.
1 of everything.
W4 plus 2A squared.
Then you got 4A squared at the end.
W.
It'll be 8, 4A, 4.
4A.
And you can double check yourself as you go. I got 2 A's, 4 A's, 6 A's, 2 times 4 is 8. I mean, I see everything kind of, I can check that I'm getting everything I need.
2A squared W4.
Yeah.
Minus.
W4 plus
Minus
2A squared W4.
2A squared.
2A squared W4.
The last one's a plus, always.
always a plus.
Yeah.
So I understand.
And the second one's just opposite of what's above.
Yeah, that's going to be minus, so it cancels out the stuff this guy brings. Right?
So the exponents add.
So there are things to memorize, but if they make sense why they work that way, it's easy to memorize them. Because you know why it makes sense. So if you memorize it wrong, you go, well, that doesn't make sense. And then you go, oh, yeah, I should have that way.
That
Oh,
way,
he's asleep. Sorry.
that was easy the way you do it though, makes sense.
I do that to people.
I said that makes sense.
I do that to people.
It really is easy. But you know how to do it because you know when you do the first two, it's always together. When you take that sign, like W plus 2A squared.
Yeah, you take that sign from there.
And then you cross them
Yeah.
out.
So don't let cubes be that big of a deal. Now, just to show you an example here, here's what trips people up. None of these had a GCF, right? So that should kind of be a
Okay,
hint.
so we're doing one more. So we're doing one more.
Hmm?
We're doing one more.
Yeah, one more thing here.
Okay.
Yes. The way it is right now,
You can have a GCF.
it's nothing. Right? The way it is right now, there's 2 terms, but can you break 5 up into 3 parts or 2?
No.
No.
But what saves your butt always is GCF. Like you said, they both have an A. Now what do you get? 4A4.
Minus 25.
Now what is this? What form is that in?
And this is
Different squares.
Different.
Squares.
Yeah, square.
So you can now break up the.
So you go, what do you say? You go, thank God.
Thank God.
2A, 2A.
2A2, 2A2.
Minus 5 plus.
Minus
Right.
plus 5, 5. I love it, right?
Yep.
So what gets people tripped up is they try to apply the cubes process to a squares problem, and that totally, obviously, won't work.
And it doesn't matter which side you have the negative positive on it.
Doesn't matter, because again, it's multiplication, I don't care. Okay.
Are you going to ever have additions that way?
The ones when you look at this equation, first time, how did you decide this is the cube and this is not cube, square?
Looking at this, 4 is not a cube, 25 is not a cube, and I can't break 4 up into 3 parts. I can break everything up into 2 parts, so I know it's a squares.
Oh,
That's how you tell the difference. Here, well, before I get too far, what about a sum of squares?
So you're adding,
X squared plus 25.
You can't do that.
I like it. You can't. The same reason this one worked. Why does this one work? Because it's a minus, they can both be different signs.
Yeah.
So the middle term cancels. If it's a plus, they both have to have the same sign, don't they? So if you think it's this,
Can't be.
there's my 25, there's my x squared, but I get minus 5 minus, I get minus 10. No? If you think it's this, same problem, right? Here's my x squared, my 25, but I get 5x, 5x, 10x in the middle.
Right.
No good. Right? Sum of squares won't work.
it is prime.
It is prime. Yeah, that one is prime.
That's how.
Cool.
So when you look, you decide that this is how you can factor it.
Yes.
Is it cubic or square?
So I desperately hope you guys remember if you do GCF first, and then what you got left has got 3 terms, you know what to try. If it's got 2 terms, it's just cubes or squares. If it's got 4 more terms, it's a grouping. Right? So you don't have to remember everything all at once. You just say to yourself, okay, it's got 2 terms. Forget everything else except cubes and squares. Which one is it? Can I break it up into 3 or 2 parts? Then I know what to attack it with. Right? That's the worst part of math is always, when do I do what? So just the last thing here, I want to show you one tiny reason, we're going to do more than this, of why factoring is important. We've talked a lot about how the hell to do it, but not about why to do it. So tell me this, can you solve that?
Yes.
Yeah.
Yes.
X is equals 7 minus 5, 2.
X equals 2, cool. Because X, you can get it by itself,
there's an equal sign.
right?
You do
You
things
can
both
get X
sides.
by itself. What about, let's see, Jeff, what do you want to do? Let's just do this, yeah. Can you get X by itself there?
Yes.
Can I combine those and get X totally by itself?
Yeah. X outside.
Why can't I get X by itself? Because here it's squared and here's, they're not like terms, right?
Yeah.
Yeah.
So whenever you have an equation where the power on the X is bigger than 1, you set it equal to 0 because the property we use is the idea that if I tell you 2 numbers, you can either look at that or you can just look at me and I just say, okay, 2 numbers multiply to be 0.
One of them is zero.
One of them has to be 0.
Yeah.
There's no other way to multiply 2 numbers and make it 0, right? If neither of them 0, I can tell you, and put all my money on it, that it will not multiply to 0, of course, right? The only way to multiply 2 things and have them come out to be 0 is if one of them is 0. So right here, A equals 0,
B is.
B.
or B equals 0. One of them, at least one of them.
Yeah.
Now how do you determine which one is going to equal?
So what does that have to do with this problem?
X outside,
Okay,
and then X plus 5.
so if I have this problem, x squared plus 5x equals 0.
Yeah.
It is equal to 0, that's cool. If only this side was a number times another number, I could use that rule.
Yeah.
And of course, like Yasmin keeps yelling at me,
So,
take an x out.
X plus 5.
And now what do you have? You have this number times this number is 0. What must be true? Either this number
X
is
is 0.
0
And X plus 5 is
or x plus 5 is 0.
Yeah.
That's an answer. And here's the other possible answer.
5.
Both of those would make this work.
So x equals 0, x equals -5.
That's the answers for this. Notice something. What power was this to?
2.
Here.
The second power.
1.
Here.
First power.
First power, 1 answer. What power here? Highest power?
2 powers, 2 answers.
Second power, 2 answers. I love it. Seems to be a pattern growing. So real quick, then here's the last one.
Third power, 3 answers, etc., and so on and so forth.
Exactly. So
Okay.
what if I add x cubed minus 4x squared equals 2x squared. Now you're going to work yourself into a corner, Jeff. Minus 8x. Cool. What's the first thing wrong with this problem? First off, can you get x by itself?
No.
They're different terms, right?
Yeah.
They're not like terms. So you know you make it equal to 0, so eventually you can do this. So you collect all your terms on one side and hope to God that what's left is factorable, right? So let's see, if I subtract the 2x squared and add the 8x,
It's gonna be a whole new God.
x cubed minus 4 minus 6x squared plus 8x.
Equals 0.
Now how do I factor that?
You can, I don't know if you can find
Take out
a
the
like
X.
term.
Beautiful, right? But you always try first. I so desperately want you to get that because you'll be so stuck on problems. If you would just look for a GCF first, you'd be fine. Take an x out.
Yeah.
X
Yeah.
squared minus 6x plus 8.
You could have taken a 2 out also.
No, careful.
So, there's no 2 there.
No
Oh,
2.
that's right.
Yeah. So how do you factor this guy now?
X plus-
Plus 4, minus 4 plus 2.
Yes.
Minus,
And then what's, now is everybody with me so far?
Yeah.
So when you have a higher power on your x than 1, you set it equal to 0? What do I mean by that? You clear one side out. Move everything over to one side, factor it. And now can either x is 0,
X 0.
x minus 4 is 0, or x minus 2, I get x is 0, x is 4, or x is 2, and that's my collection of answers.
3 powers, 3
So
answers.
that's section 5-8.
Sweet.
5, 8. So we finished 6, 7, 8.
That's 5-8, yeah. 5-7 is just a review section, really.
Oh, so we went through
5-7,
7
they
and
put
8.
all the forms of factoring all
Holy
over.
crap.
So where should we be by Wednesday?
Have all 3 assignments done.
I'd say by Wednesday you should be maybe getting into 5-7 at least, yeah.
Homework wise.
Yeah.
Okay.
So I know a few of you guys actually got through 5-8 done, because you remember this stuff from before. That's awesome. Some of you guys got through 5-8 done, but you didn't remember it from before. So you're going to have to do them over. So,
So today we finished 6, 7, 8. 5, 6, 7, 8.
and of course, when would that homework be due?
And then test.
Yeah.
Well, true, but when's it due?
Good
As a
last
rule of
year.
thumb, next Monday, right? Just so you know you're on track. Okay, cool. All right, guys. See you Wednesday.
Now, what is that?
Can't even move right now.